I don't know the exact time, 10, 12 minutes or so. So I want you to check and make sure that your table and graph are correct. Because if you have the table and graph wrong, then your answers. So let's look and see. Let's talk about this real quick. If we are flipping the curve, here's the sine curve, the sinusoid, the wave. There's one cycle from 0 to 2 pi. When I fill in the cosecant values, this is the reciprocal of sine. Okay, so sine at 0, but the reciprocal of 0 would be undefined. Okay, sine at pi 6th is 1/2. The reciprocal of 1/2 is 2. Okay, sine at pi halves is 1. The reciprocal of 1 is 1. Okay, so I go through, that's where I'm getting these values. You can be using your unit circle to do that if you prefer. Some of you can do that in your head. Some of you need to physically look at it. Just know when we test next week, you won't have a completed unit circle to look at unless you fill a blank one in while you're testing. Okay. So you've got to fill in the table. So when we go to plot these, if we go to at 0, pi, and 2 pi, it's undefined. So there's vertical asymptotes at 0, pi, and 2 pi. Now in between there, okay, they share some points, like at pi halves and 1, that's part of the sine curve and the cosecant curve. At 3 pi halves -1, that's part of both curves. They're both at -1. Okay, but then in between the asymptote and that vertex, okay, it's up at 2 because it was at 1/2. The reciprocal of 1/2 is 2. So it's like you're taking this little U-shaped portion and literally flipping it to the opposite direction. Okay, same thing here. You're taking this little U-shaped curve and flipping it down. Y'all see that? So it's like instead of the curves coming into each other, they're flipped to go away from each other with asymptotes in between. So there's a discontinuity between each of those. Does everybody feel okay with where this came from? Okay, so this is the cosecant parent function. Okay, with asymptotes, so this is still the period, isn't it? Once we get past this asymptote, that's where it would start repeating and be up here again, wouldn't it? Okay, so the period did not change. The period of sine was 2 pi. The period of cosecant is still 2 pi. Okay, so the period remained the same, but we did have to add in these asymptotes. So you need to know the spacing between the asymptotes. So how far apart are each of these asymptotes? Pi. 1 pi radian between each asymptote. Okay, so hopefully you can use this now to be answering some of the questions underneath. And then when you get more toward the bottom, there, I think it's number 7, there's a spot for you. Let me pull up the blank one here. Right here on number 7, there's a spot where the cosine parent function is, and they want you to graph secant on it. If you need to make the little table like we did up here for cosecant, if you need to make a table of values, you can, or you can understand the relationship. If this is how sine and cosecant are related, don't you think that's how cosine and secant are related, since those are reciprocals as well? And cosine is this same wave, isn't it? Just slightly shifted over, right? Okay, so you can make a table if you need to answer number 7, or some of you will be able to just come up. Notice that anywhere an x-intercept is on sine or cosine, that becomes an asymptote on its reciprocal. Okay, so you should be able to get the cosecant, or excuse me, the secant graphed on top of the cosine graph here. And then number 6, pay attention, it's asking about secant, not cosecant. So you may actually want to graph 7 before you answer 6. Okay, so these first 5 were about cosecant, and then it changes and starts talking about secant. And then number 8's asking about both. the periods. Okay, so I'm gonna give you all a couple more minutes to finish that out, and then we're going to go to the front of that second page I handed you. It has the blank space here for quick notes, and then some check for understanding. Okay, so we're gonna fill in half of these quick notes together. I'll give you all about like 7 more minutes or so, and then we'll do this. And then you'll be able to try and answer the check for understanding questions about secant and cosecant. If we have time, y'all can move into starting on the back, talking about tangent and cotangent. Okay, but I don't worry if you don't get to that today. We'll do tangent and cotangent tomorrow. Okay, but we definitely need to finish secant, cosecant today. If you don't get all of those check for understanding questions about secant and cosecant answered today, you'll want to do that at home. So when you come in tomorrow, we're ready to jump into tangent, cotangent. Okay. All right. So I'm going to freeze the screen up there again and give y'all about 7 more minutes, and then we'll do the quick notes together. All right, I'm going to keep talking over here because I'm recording, but y'all can ignore me and keep working. All right, so in the video, instead of having an empty video for 7 minutes, I'm going to go ahead and through the rest of this so you can check your work. Pause the video here and try the problems if you weren't in class for them, okay? And then unpause and come back to check them. Here's 2 and 3. Okay, so the values of theta, where the vertical asymptotes are, and the values of theta, where cosecant and sine are equal to each other. And I actually did kind of mention that already. They shared those points here and here. Okay, it's at the vertex of those curves, at the vertices. And remember, when we're saying where the asymptotes are, okay, you can list them out, but dot, 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 because we know that it keeps going forever. So that pattern would keep continuing past this one cycle. So sketching the cosecant curve on the same axis as the sine curve, that's what we did up here already. Okay, so that's the graph itself is number 4. Okay, here's your range. Okay, in interval notation versus inequality notation. Okay, I prefer interval. And then 7 is the one where you should have graphed over the cosine curve, graph the secant curve, which the same thing happens. The curves just flip and open out away from each other instead of towards each other and connecting. So whenever those zeros were on cosine, those become your undefined values here. Okay. Now, what's graphed here is more than one cycle, because technically one cycle is just 2 pi. So if we started at 0, it would end here, and then you can see it just starts repeating what it had here. Okay, so this is just showing a little more so you can see that the curve does complete to the next asymptote. But this shown is actually more than one cycle. It's bigger than one period. Okay, now speaking of the period before it starts repeating itself is the 2 pi. It's the same as cosine and sine's period for the parent functions. Okay. I'm going to go ahead and stick this all in one video. If you're doing this over 2 days, the back side goes over tangent and cotangent, which we're going to cover tomorrow. But if you're watching this as a video, you can go ahead, give it a shot, and check your work. On the second page I gave you, though, there is, let me show you the actual Word document. Second page looks like this. It has the quick notes, but we're combining all 4. So you're actually going to draw a line down the middle here. Okay, and we're going to talk about secant and cosecant on the left, and then we'll talk about tangent and cotangent on the right. So you're going to have to write a little smaller than what I'm showing you, because all of this needs to fit in half of that box. We want to have the cosecant and the secant parent functions listed, and make sure that we know the period of both is 2 pi, and where the asymptotes occur. So the asymptotes for cosecant occur at every multiple of pi. So in pi, and it's x equals because it's a vertical. So at x equals 0 pi, x equals 1 pi, x equals 2 pi, okay, and so on and so forth. For secant, the asymptotes start at pi halves, but you can't just say pi halves in because that would include 0 pi halves, which is just 0, and there's not an asymptote at 0. Or if it was a 2 pi halves would just be pi, and there's not an asymptote there. So it's not at multiples of pi halves. It starts at pi halves, and then it's spaced out a full pi in between. So it's pi halves plus pi n for the location of the asymptotes for secant. Okay. This little note in the middle just says to graph with at least 3 asymptotes to see one full period. So that's here from this asymptote at pi halves to 5 pi halves. You can see one of the lower curves and the upper curves. Okay. But you could have also started at 0 and stopped at 2 pi. That's still one full cycle. It's just cutting both of those graphs in half. So if you'd rather see full curves, not cut in half, you can go from pi halves to 5 pi halves and have 3 asymptotes. Okay. All right. And then the second page underneath this had some for understanding, but I'm going to flip back to tangent. So this is this one that says, let's go off tangent. So this one should be done on Friday. So if you're here Friday and you've already done it, you're just checking it, getting answers, or answering some questions you were confused about, great. If you haven't done it yet, pause the video here and give this a try first. Answer what you can and then come back and watch the video. All right, so here's what we should have gotten for tangent graph and table. Okay, so we know that tangent, it's not the reciprocal of sine or cosine, it's the ratio of sine over cosine. Okay, so we know the tangent values around the unit circle. We should know those. Okay, this is all multiples of 45. So this is going every 45 degrees. So you can see if I go to plot these, I've got the vertical asymptotes wherever tangent's undefined, which is anywhere along, I would be on the y-axis for the unit circle. So up at pi halves and at 3 pi halves, negative pi halves, if you go in the negative direction. So you can see those vertical asymptotes, and then in between are okay, pi and 2 pi. So the zeros are at multiples of pi. Okay, and then in between those, we've got the tangent values at 1 or negative 1. So it creates in between the asymptote these curves that are increasing from left to right. Okay, so this is what your tangent graph should end up looking like. Now, this one ends up having a smaller period than sine, cosine, secant, and cosecant, because you do one of these curves, you get to the next asymptote, and it repeats. So it's not having to have like one opening up asymptote, one opening down, another asymptote, and then repeat. It repeats between every single asymptote, and the asymptotes are spread out the same as they were for secant and cosecant. So that means the period is shorter. The period is half of what it was for the other 4 trig functions. Okay, so keep that in mind. So the period is only 1 pi. So that's the distance between asymptotes is 1 pi. Okay, because those outputs repeat themselves after each asymptote. Okay, now the domain. The domain is everything except the asymptote. So we'll just list that as all real numbers. It cannot be, and then you can list out the exceptions, or in mathematical notation, that would be all real numbers. Theta cannot be pi halves plus pi n, because that's the intervals where the asymptotes are happening. Okay, where n is an integer. Okay. Now the range goes down forever, it goes up forever. There's no break in the middle like there was for secant and cosecant. So the range was just all reals. Now, cotangent is the reciprocal of tangent, or it's cosine over sine instead of sine over cosine. So the only thing that changes is the direction of these curves between the asymptotes, okay, and the location of the asymptotes. So here we had a 0 at the origin. Here for cotangent, you can see at the origin we have an asymptote because the reciprocal of 0 is undefined. So where tangent was 0, cotangent is undefined. Where tangent was undefined, cotangent has its zeros. So that's at pi halves and 3 pi halves, etc. Okay, so it's a very similar graph, but it's decreasing left to right, and it's shifted slightly. It's got a phase shift from the tangent because where the zeros and asymptotes were are flip-flopped. So then listing out where those are, okay, same concept, except this time it starts on the axis, so it literally is just every integer of pi. So we can just say x equals pi n, okay? Now the period we said was different for tangents. It's the same thing for cotangent because they're reciprocals. It's 1 pi between those, okay? And so then on the quick notes on the right half that you left blank yesterday, or when you did secant and cosecant, we want to fill this in for tangent and cotangent. Okay, so you can pause the video to get that jotted down. Okay, and then you try the check for understanding. So pause the video, try the check for understanding, and then come back to check it. Okay, so if you have already tried it and you're coming back to check, you need to remember that a 3 in the b value affects the period. So remember, the period is 2 pi divided by b for sine and cosine. So that's something extra for tangent that we need to know. Since the period is only pi to begin with, to find the period from the equation, it's not 2 pi divided by b, it's going to be 1 pi divided by b because the period is shortened. So it's just pi thirds. So that is horizontally compressed. These asymptotes got a lot closer together. Okay. Here, write equation for a tangent graph below. So we can see those points of inflection where in the middle that are considered like our center have been shifted up off the x-axis. So this one has a vertical shift up. Okay, and then actually it shouldn't be +2. That should actually be a +1 because that point of inflection isn't up at 2. The point of inflection was just shifted up 1. But then your asymptotes between them, you can see this is at pi fourths. And then to 3 pi fourths. So there's only pi half between them. So this has been horizontally compressed by 2. So your B is 2. And then on these, and these may not all be on the check for understanding for the worksheet one that y'all have because we combined both of them, but some of them are. They may just not all be there, but you can check those, and I'll go back and let you check the check for understanding for the secant cosecant ones as well. Okay, so here were the ones from secant cosecant topics. Okay, same thing, our b value of 3. So 2 pi divided by 3 would be our new period. So that's the spacing between asymptotes. Okay. Here's those equations, what they come out to. This one's been reflected. Y'all have a good day. Do the check for understanding for secant, cosecant. Okay, and then that's it. All right. Stop that video there.